Hi, welcome to another Python video. In this video, let's take a look at repetition structures and looping in Python. Repetition structures and looping in any programming language become a very powerful tool when you combine it with iterables like arrays, lists, dictionaries, tuples, things like that. We're going to take a look at one of the simplest and most basic repetition structures in Python. And that's a very simple for loop, okay? So we have some code here, and we define, in this case, a list, the 6 main characters, and MLP friendship is magic. And we set a counter variable up outside the for loop here. We initialize it to be 0. Now remember, these are indexed. Not 1 through 6, but 0 through 5. It's still 6 elements, but with a list or an array, you have that off by 1 issue. So you start at 0, you don't start at 1, but still 6 elements. Here is our basic for loop repetition structure in Python. So for, this could be anything. You can call it W, you could call it foobar, you could call it Monty Python, supercalifragilistic, whatever you want, but it's just a variable that you declare that will hold the position, the index value of the iterable object that you're going to iterate through in your repetition structure, in your for loop, okay? And then in main character array, well, that's the name of our list object, aka array, defined up here with our 6 main characters. We're going to simply increment the counter object here, and we're going to say counter equals counter plus 1. I coded it that way to make its what it's doing more what's the word I'm looking for? I can't remember. Now we're going to take our counter variable and we're going to add 1 to it. All right, it's going to accumulate 1 every single time we iterate through this loop. And that way we can sort of count what's going on in this very simple for loop. And I wrote it this way to make it more transparent about what it's doing. But instead of saying counter is equal to counter plus 1, there's a shorthand method to do this in Python. Plus equals 1, all right? That's the same thing, just sort of you'll see that a lot in Python code, and there are other variations of that in PowerShell and C++ and Java and PHP and different languages like that. Okay, and then we're going to simply, in a print statement, display, in this case, counter. That'll hold the auto-incremented value as we iterate through our for loop. And then W, that's the variable that indexes the object itself. That'll display the name. And then this sep is equal to the 2 single quotes. We just don't want the print method to automatically add a space because we're doing that ourselves after the period here. We just want it to auto number. So if I hit F5, we'll run our function. And look, loop method 1, here is every single value, every element defined in our list and our array, and they are numbered by the counter variable here, 1 through 6. So there's our 6 main MLP characters, right? All right, let's take a look at another example of a repetition structure in Python. We'll comment out the first function, and we're going to go run the second function. And in our second function, we have also defined a list, an array here. And this is a little bit different. We're going to use a repetition structure, a for loop, but we're also going to use this range and len. Okay, range and len. Len will automatically return the number of elements inside of a list type object, a Python array. Okay, so that's what we're using len for, to automatically get that. That way we don't have to hard code it. We don't have to, if we change the number of values in our list, in our array, then length will return that new value. So it makes our code more dynamic to use len instead of a hard-coded value. But also range just says take the starting value and go to the ending value in a for loop. And if we do it that way, if we use a combination of range and length, then we can make this syntactically more like a for loop would work with an array in C++ or Java or PowerShell. Okay, it just gives us that capability. So now, instead of x being the actual object, x will become the number, the index or the subscript value of our list, right, up here, our array. So I'm going to add x plus 1 because I want to number 1 through 6. If I didn't add the plus 1, it would number 0 through 5. Remember, that's how lists and arrays work. It's off by 1. So I may have 6 elements, but they're numbered sequentially 0 through 5. They're not indexed 1 through 6, they're indexed 0 through 5. So hence I'm adding a 1 here, period, doing the same thing, but also notice these square brackets. That's how I access the element. So this is now a numerical value as opposed to an element object value. And syntactically, sometimes it's just more versatile, more convenient to do it this way. And it also makes it work logically the way it would work in another language such as C++ or PowerShell or Java. But if we run it, we'll essentially get the same thing. So I have F5. Let's see what happens. Okay, and again, here's our 6 main characters, numbered sequentially. Let's look at another example. We'll go look at a third function here. Okay. Our third function, we're going to use range with for, and we're going to approximate C++ syntax, okay, and or PowerShell or Java. So here we don't have a list, we don't have an array. We're just going to count, all right. And x, instead of being an object, since we're using it with range, it's just going to be numerical. Range, our starting, the start of it will be 1. The end of it, we want it to end at 10. But again, because it's off by 1, we want to add 1, or I could just say 11 if I wanted to type 11. But to make it more transparent, since I want to count from 1 to 10, I'm just adding my 1 on there, okay? And if I were to run this, all right, so see, I'm just counting from 1 through 10 down here. Let's take a look at another example, another repetition structure function. Are you starting to see the usefulness of these repetition structures? When you combine them with lists and dictionaries and iterable type objects, you can do all kinds of wonderful things. You know, everything from database programming to game programming to graphics and things with Tkinter. Just wonderful functionality with these repetition structures. Let's go look at function 4. I'm going to scroll up here. Okay. Another repetition structure. We have a list here, an array, and this is using a while true loop, all right? We've been using for loops up until now, but in this fourth function, we're going to use a while true loop. A while true loop will continue to iterate and loop and repeat until it reaches what's called the sentinel value. Okay, so here, while x is less than the length of the main character array, that's our list, it's got 6 main character objects stored in it, I'm going to repeat or iterate in this loop. And again, I'm just going to display the value of x, right? It was initialized to 0 outside the while true loop. And at the bottom, I'm incrementing or adding 1 to it. And remember, I did this to make it more transparent, but remember, you can do this. X plus equals 1. Just a shorthand way of incrementing a value. And you can do the same thing with decrementing. Incrementing, you can decrement. I could subtract the value. But that's not what I want to do. In this case, I want to increment and not decrement. All right, so while x is less than the length, automatically turns the number of elements in the array, 6 main characters indexed 0 through 5. Display them, and remember the square brackets? That's how we access the subscript or index value inside that list in the array, okay? So let's clear the console, and if I run this, there. Okay, so twilight sparkle indexed subsequently. In our while true loop. Okay. Let's take a look at another function or example. And we're going to go run function 5. VS Code is acting hokey today with my mouse cursor doing all kind of weird things. But that was function 5. Alright, another while true loop. Example of a repetition structure of it. Again, we have a list object, an array. Again, we initialize x to be 0, while x is less than 3, okay? And let's see what happens here. Okay? And in this case, by changing the value here, the condition portion of the while true loop, we just changed the number of elements we displayed. We only displayed 3 instead of 6. Okay, let's look at the break statement in the next function. That can be useful. Although I prefer to code repetition structures to reach a sentinel value. I don't like hard-coded breaks. They can introduce sometimes unexpected consequences, but it's up to you. As a developer, you decide. I just want to make you aware of, the use and the syntax of a break within a repetition structure in Python. So here in function 6, we have the same list. We've defined the array. X is initialized to 0 outside the while true loop. The condition portion of our while true loop, while x is less than 6, okay? But something's going on here. We have a decision structure. Hey, if x evaluates to 2, we're going to say sentinel value attained, breaking out of the while true loop now. The sentinel value is a value that you test for. It's like a trigger. And if you detect that value, then you use it to break out of a repetition structure or some other action. But in this case, it would be break. So if x evaluates to 2, we break, and that will end the while true loop. Even before x reaches a value where it's no longer less than 6. So if we were to run that, let's clear the console down here, and we will run it. Okay, so it counts, right? X starts out at 0. 0 is twilight sparkle. It's incremented. We add 1 to it. It becomes 1, Fluttershy. Then we add 1 to it. It becomes 2, Rainbow Dash. But then after that, X is now, it evaluates to be 2, right? It now is the value 2. So that is our sentinel value. That's what we coded in our decision structure. So sentinel value attained, it calls break, and it breaks out of the loop before it gets a chance to display the remaining 3 MLP Friendship is Magic characters. So it's just Twilight Sparkle, Fluttershy, Rainbow Dash, then sentinel value attained, breaking out of the while true loop now. So there's an example of using break in a while true loop. All right, you can use it in for, you can use it in while. Let's take a look at another function. And we'll run function 7 here. Again, we have our list type object, right? Our iterable, our array. Again, we're initializing x outside of the while true loop. Again, our condition is while x is less than 6. When x is no longer less than 6, when that becomes false, that would be our default sentinel value where we would break out of our repetition structure, our while true loop. But continue is sort of the opposite of break, whereas break would force it to exit the repetition structure, the while true or the for loop. Continue has it pass over the code beneath it and just go back up and to the loop process and iterate again. So what would the effect of using continue be in our code? Well, let's think about it. While s is less than 6, well, x starts out at 0. So the first time through, we print element 0, which is Twilight Sparkle. If x equals 2, no, it's not 2, it's 0. So we skip this, and we add 1 to it. The next time through the loop, we iterate. X is no longer 0, it's 1. And so we print rainbow dash. Does X evaluate to 2? No. So again, we skip this block, add another 1 to it, increment it, and now 0, 1, 2, so it displays a rainbow dash, okay? But now this condition is true. X evaluates to 2. So what happens? Target value trigger, continuing with while true loop, now skips the increment, so becomes an infinite loop. Why? Because look, we used the keyword continue right after that. If I do that, it's sort of like break, but instead of exiting the loop, it stops the execution of any code below it and just simply goes back up and iterates again. And because I coded it such that this condition is if X is 2, well, X will remain 2. X doesn't increment after that because of continue. So no more is added to it, so it will just remain 2 forever. So this will basically create an infinite loop, not something that we want. So again, it's there for you as an option, but I'd be careful with using lots of break and continue in your repetition structures, because it can introduce all sorts of unforeseen consequences, such as this infinite loop here. If we run it, I'm going to press F5. Boom! You know, we've trapped ourselves in an infinite loop, not being not discretionally using the continue keyword. I'm just going to go ahead and stop this debugging process, and we will clear it. Let's go look at the next function. So we've got for loops, and we've got for loops with a range that will give you an index and subscript value to access objects the way you would in C++ or Java or PowerShell. We've got while true loops, okay? We don't really have do while loops, but we do have while true. Let's look at using else with a while true loop. You can do that in Python. So again, here's our list, our array, initializing X outside the while true loop, the same condition portion in parentheses of the while true loop, while X is less than 6, will display the characters. We're going to increment or add 1 to the value. And then else print sentinel value attained, so exiting the while true loop. And then this is just, we're not using break, we're not using continue, there's no decision structure inside the while true loop, so it's just going to be the default value. X starts out at 0, and when it's no longer less than 6, all right, not equal to 6, but less than 6, then that's the default sentinel value. We'll break out of that loop. Let's hit F5 and run it. Okay, and there's our 6 main characters, all right, from MLP. And then what happens? The else portion is executed at the very end when the sentinel value has been attained. Sentinel value attained, so exited the while true loop, okay? And we said there's no do while loop. So in other languages such as C++, and Java and PowerShell, you have a do while loop. And that can be useful because depending on what you start out with in your condition portion for a for loop or for a while true loop, it may never execute if the value is already outside the condition portion or the range of what you're testing for. So in languages like Java, C++, PowerShell, you have a do while loop where normally you test a condition after the iteration, or excuse me, you test the condition before the iteration. In a do while loop, you test the condition after the iteration. That way you can guarantee that it always executes at least one time. You don't have that functionality in Python, but you can emulate or simulate a do while loop like this. Let's look at function 9. Again, we have our list, our iterable, our array. It's got 6 elements stored inside of it. And then we set our counter object. We're going to get the length, the number of elements stored in the array, and we'll assign it to pony count, okay? And I'm just going to have this statement. Instead of a condition in parentheses, I'm just going to put while true. And if I didn't provide a break or a sentinel value, that would become an infinite loop. While true starts out as true, it's always true until it becomes false. So we're sort of approximating a do-while loop. What am I going to do? I'm going to display a main character. And then if pony counter is greater than or equal to pony count minus 1. Why? Because the number of elements returned by length will be 6, the actual count of the number of elements in the list. But remember that it's off by 1. All right. There's that fence post issue. They call it fence post because if you were looking at fencing, and you might count the posts instead of the partitions between the posts, and you might be off by 1. But it's that off by 1 situation where you don't start counting or indexing at 1, you start counting and indexing at 0. So 0 through 5, that's still 6 objects or 6 elements, but we just index it beginning with 0 rather than 1. Okay, so I'm subtracting 1 here because I don't want to go from 0 to 6. If I did that, I would be accessing a null value. That object doesn't exist, and then that would throw exceptions, and I'd get errors. I'm going to subtract 1 to make sure that I don't go beyond the last element in the array. So if it's greater than or equal to pony count minus 1, in this case 5, what? I reach the sentinel value, breaking out of the while true loop now, and I break to break out of it. Otherwise, I'm just going to keep incrementing, and that will advance us through our while true loop. This would guarantee that our code would run at least once before the test, because the test condition is inside the while true loop. So this is sort of Python's version of a do while loop. Okay, achieves the same result, just syntactically a bit different, or how you would code it. Let me clear the console and we'll run this code. And there you have it. There's our 6 main characters, and then we reached our sentinel value, and we break out of that repetition structure, that while true loop. Without that sentinel value, without testing for it and breaking, that would just be an infinite loop. Okay? Thank you for watching this video. If you liked it and you'd like to see more videos of this nature, please click on subscribe and click the notification bell. And the next time I create a video and post it, you'll be notified. Thanks for watching.